All right, let's get started here. I would like you to fill out daily question sheets this week. So if you haven't already, you might want to pause this, grab one, and fill it out. There will be a question of the day at the end. First of all, let's take a look at the homework. So you're supposed to do 1 through 10 on 7.2 and 7.3. I won't be stamping this since I'm not here, but I'm going to put up the answers for you to check. So, let's go back here. This would be a good place to pause the video and check over all of your answers through 1 through 10. So I'll stop here a couple seconds, but you guys can pause it to check. Okay, so hopefully all those make sense. Remember, when you're naming compounds with polyatomic ions, you don't need to change the N to IDE. You just list the name of the cation, and you put the name of the polyatomic ion that's there. So really the hardest part of these type is just recognizing what are polyatomic ions. And so that's why it's good to go through that polyatomic ion sheet and kind of get a feel for some of those. But you should be able to obviously separate those. The hardest one tends to be number 10, like number 10 here, where you have ammonium. So we have there's actually two positive polyatomic cations, but ammonium is the most frequent one, and that one a lot of people will miss because they'll look, okay, N, and then think H4, NO3 is a anion, but just get used to seeing that NH4. Try to break those up into the obvious groups based on the polyatomic ion sheet. Okay, let's go on to 7.3. Again, I'll get this down to number 10, and you can pause it and check through all of your answers. So, these are maybe a little bit harder than writing down the names from, if you're given the formula, writing the formulas down. Remember, we put these together based on the charge. So, a good thing to do when you have a list of these is just to go through, and before you even write any of the formulas, just go through and figure out the charges of each. Okay, what's the charge of aluminum? What's the charge of the carbonate ion? What's the charge of potassium? What's the charge of hydrogen phosphate? Just go down and put the charges above all of them. It makes it a little bit easier to come back where you're not having to flip back and forth all the time. But the other thing here is to remember, if there are two or more of the polyatomic ions, you need parentheses around them. If there are two or more of a monatomic ion, like potassium or aluminum, since those are single elements, we don't need the parentheses. And then we don't need parentheses if the polyatomic ion only has one. So like in number 8, we have two lithiums there. There's only one carbonate. You don't need parentheses around the carbonate. And that, probably just going to take some practice, doing enough of those where we get used to it. Okay, right now, I would like you to pause this video and do the rest of the questions. So if there's ones that you're struggling with, ask a friend, try to figure it out, or if there's one you just really don't understand, put a star by it. Come see me in the morning tomorrow. We'll get it figured out. But really getting these down is just going to take practice. So finish the ones 11 through 20 on each page. Pause the video here, and then we'll go check those. All right, let's go back and check 7.2, 11 through 20. Okay, there we go. The thing that makes these different, of course, is all of our cations here are going to be ones that have varying charge. So we need to have the Roman numerals in the names to show those charges. So remember, it isn't that there are two tins. That's not what we call a tin 2 nitrate. It's that the charge of the tin has to be 2 to balance out the nitrates on the other side. Okay, and then just as a little bit harder, maybe a little trickier one, number 20, Hg2 is our other positive polyatomic ion or other polyatomic cation. So dimercury is an actual polyatomic ion. If you put mercury, let's see what would be, mercury 1 perchlorate here, I actually probably wouldn't count it wrong. That is a tricky one. You got to kind of watch out for it. So I would probably take mercury 1 perchlorate and give you full credit on that if you did that on a test. Although, because that is a trickier one, I probably wouldn't put it on a test. Okay, so hopefully you've paused and checked through all your answers on 11 through 20. Then let's go on to the next side and check 11 through 20 there. So here we're going the opposite way with cations that have varying charge. Okay, ignore this thing right here. I was showing what the difference between something, a correct answer and a wrong answer would be. Oh, dang it. Kill this stuff off. So pause your video here, check all your answers. Okay, now personally, I kind of like doing these where we're doing the compounds, doing the formulas from the names where we have varying charge, because you don't have to look anything up. For example, on number 15, I have to look up what chromate's charge is on the polyatomic ion sheet, but I don't need to look on the periodic table or try to remember lead. It tells me right in the name that lead has to be a +2. So we figure out lead is +2, chromate is -2, so they balance each other out, and we just have PbCrO4. Okay, so remember on these, you're just doing the cross-down method in most cases. Just make sure you reduce if you can. If you're really struggling with these, you really need to come in so that we can go over stuff, or find somebody to tell you how to do it. There are online things that will show you. Definitely don't be afraid to, just Google nomenclature, chemical nomenclature, and go from there. But if you can't get this stuff down, I mean, really the rest of the course is going to be, it's going to be tough, because there's in all the chemical equations and things like that. I should be able to, from this point on, just put copper 1 sulfite, and you should be able to figure out what the formula for that is. And so if I say copper 1 sulfate reacts with hydrochloric acid, you should just be able to put those formulas down, and you're not going to be able to do the actual chemistry if you can't. And so this nomenclature stuff is pretty important. It does. I think it just takes a bit of practice. That's why we have so many problems that we're doing here, and we'll do more throughout the week. But if you're really struggling and you don't understand it at all, come see me. Let's get it figured out. All right, today, as our daily objective said, we're going to learn how to write names for covalent molecules. Apparently I don't have something plugged in here. All right, so covalent molecules, remember, are molecules that are made when both atoms have similar electronegativities. And for a bunch of reasons that I'm not going to get into, we really only see that happen for atoms where both of them come from the right of the stair step. So if we think about the periodic table, we have that stair step that kind of goes down between aluminum and silicon and germanium and astatine and all the way down through there. And so just from the right of the stair step, we have molecules that are formed by those atoms. And, of course, the noble gases don't fit into that. The thing that we have to remember, of course, is that hydrogen can sometimes find its way in there. Although generally when hydrogen's in, that's an acid. So we're not going to see that too much. Really the only one that you would see, a covalent molecule that is made of hydrogen and something that is not, we don't name it as an acid, is water. And water we will talk about a little bit later, how it's a little weird because it sort of fits into a bunch of different places, and we can actually name them, name water with all three systems. We'll talk about that later. But for the most part, all of these things come from just a few elements, just putting them together in different ways. So a good example of a covalent molecule that you probably heard of is CO2. Okay, so in this case, carbon and oxygen both come from the right side of the periodic table. But because it's a covalent molecule and the electrons are shared, we know a lot of times they follow the octet rule, but not always. And so it's not quite as straightforward as naming ionic compounds where we know the charges have to balance because there's all these coordinate covalent bonds and things like that. So in this case, we actually use prefixes. So I'm sure you know the name for CO2. This is carbon dioxide. Okay, and I would like to contrast that with another similar molecule made of carbon and oxygen, but quite different in its chemical properties, and that's carbon monoxide. Okay, and here the names, I mean, obviously they tell you what elements are in, but the prefixes basically tell you how much, how many of each atom there are. So here the di tells us there are 2 oxygens. The mono tells us that there's only 1. So let's put down the prefixes for all the numbers 1 through 10, and then I'll show you how to use those, and then we can go from there. So the prefix for 1, as we already said, is mono. The prefix for 2 is di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8, octo. 9, nona. And 10 is deca. Oops. Okay, so it might be a good idea to pause the video here, write these down. So for covalent molecules where both atoms come from the right of the stair-step, we simply put prefixes in front of each of the names of the elements. We still change the second one to IDE, so instead of carbon monooxygen, it's carbon monoxide. But the other little trick here is that mono is only used on the second element. Okay? So, for example, here with carbon monoxide, we didn't put monocarbon monooxide. That would be, maybe a little bit more specific, but for whatever reason, if there's only one of the first element, we leave the mono off. We use all the rest of them on the first element, but mono only applies to the second element. So, for example, if we had something like this, okay, we would still use the prefix on the first one here because there's more than one. So this would be trisulfur. And you notice here we don't change the first element to IDE. So it's trisulfur pentafluoride. Okay. But if we had something like this, SF6, here there's only one of the first elements, so we leave off a prefix. We don't use mono. So this would be just sulfur. And then since there's 6 fluorines here, hexafluoride. Okay, you will not have a prefix list or something like that. You actually have to know your prefixes, so this is something that you have to memorize. I would bet that other than hepta and nona, most of the rest of those should make sense. 10, deca, decade, 10 years. Octo, octopus. Hexa, maybe you don't know hexagons. You probably should have heard of, though. Hexagons and pentagons. Oh, tetra might be the other one, because a lot of times we hear quad or something like that, but tetra is the prefix for 4. So there might be a couple of those you have to kind of memorize a little bit, but most of these you've probably heard of before. They should be fairly simple. Now the beauty here is going from, you have to know your prefixes and think about those rules, changing them to IDE if you're going from the formula to the name. But going from the name to the formula is pretty simple. So if we have something like this, okay, tetranitrogen heptachloride. If you know your prefixes, there isn't any looking charges up or crossing anything down. Here, the prefixes tell you how many of the element. So, tetra is 4. I have 4 nitrogens. Hepta is 7. So I have 7 chlorines. So my formula would be N4Cl7. That is the chemical formula for tetranitrogen heptachloride. So, covalent molecules tend to be fairly easy. Like I said, you just have to memorize those prefixes, and just you can't forget that if there's only one of the element, on the first one we don't use the mono. Mono is only used when you're doing the second one. All right, let's see here. Homework for tomorrow. Where did I put those sheets? So we should be completely through 7.3 at this point. Yeah, 7.4, which is on the back of 7.3. So 7.4, you've got 20 formulas there that you have to write names for, and then 7.5, you have 20 names that you have to write formulas for. So those two are going to be what we check tomorrow for homework. You have the rest of the time to work on those. Good luck. If you have any questions, come see me in the morning. I would assume these covalent molecules should be fairly simple. If you're struggling with any of the ionic ones, the ionic naming, come see me. We'll figure it out. All right, let's find your question of the day. Ignore the date there. I didn't change that. But what is the formula for copper 3 perchlorate? Let's write that down for your question of the day, and I will see you tomorrow.